Question 46 is asking us to find the values of x when y is 0. So all we're looking for are x-intercepts in this case here. And so when you do this, you just follow the graph all the way down to where the x-axis is, and then you go ahead and mark what those two values are. So looking at this first one here, here's the x-axis right along the horizontal side here, and we look at this point right here, and this is 2 spaces from the origin, and this is 1, 2 spaces, so -2. So our answers are -2 and 2. Those are the two x-intercepts, or they might call them real roots. So this one right here is -1, and this one is +1. So -1 and 1 are the two answers here. And let me fix that for you real quick. So looking at the next one, we follow the parabola down until it touches the x-axis, and it looks like it touches it right at this point here, so I call that -2, and this point right here at -4. So -2 and -4 are the real roots, or the x-intercepts, for letter C. And the last one, so we have a x-intercept at this point right here at +2, this point at +4. So 2 and 4 are the two x-intercepts. Well, here they're asking us to use the discriminant. So question 47 is use the discriminant to find the number of real solutions or x-intercepts. And there's only going to be 3 possible answers. You're either going to have 0, you're going to have 1, or you're going to have 2. Now they have 4 distractors. Distractors are possible answers there. So one of the answers is not going to make sense at all. So it's either 0, 1, or 2. You can either have no roots, 1 root, or 2 roots. And so the way we do that is you just use the discriminant. Use your A, B, and C values. Make sure it's set equal to 0. And all of these are. This one doesn't have the equal sign, so we'll say it's set equal to 0. And we just use this portion, this b squared minus 4ac. And remember, if it is equal to a negative, there's no solutions. If it's equal to 0, there's 1. And if it's a positive, there's 2. So we go ahead and substitute in there. 2 squared minus 4 times by 3 times by 8. So you end up with 4. Now, whenever your A and C terms are positive, that means that we're going to always subtract, because there's only going to be one negative. And this makes 12 times 8 makes 96. So you definitely have a negative number here, negative 92. So whenever it's negative, so negative sign right there, that tells us that we have no roots, no solutions, no x-intercepts, or the number of x-intercepts is 0. So that's our answer there. And the next one, again, you're just taking the A, B, and C values, substituting them in there, and you end up with a b squared, so it's going to be 6 squared minus 4 times a, which is 1, c is 9. So you end up with 36 minus 36, which is 0. So this tells us we have one solution. One root is our answer there. So here we had none, 0 roots, or 0 solutions. Here we had one solution. Let's take a look at this next one. We do a is 2, b is negative 4, c is negative 3. So it's the opposite of b. Well, actually just negative 4 being squared, minus 4ac, so 2 times by negative 3. Notice that c is negative, a is positive. Whenever these are opposite in sign, it means we're going to have an even number of negatives. Notice how this is always going to be positive, but the negative and the negative here make a positive, so this is going to be 24. So add those two numbers together, we get 40. So since it's a positive 40, that means we have 2 solutions, 2 x-intercepts, 2 roots. Is what the answer is there. Well, this last one, here we have an a, b, and c values. So it's negative 8 being squared minus 4 times by 4 times by 4. So 64 minus 64 makes 0. So this tells us we have one root, one solution, one x-intercept. So that's question 47. Let's take a look at 48 through 50. It's applications of quadratics. So there's two different types they can give us here. There's either going to be projectile problems or area problems. So there's an example of each of the types. And so let's take a look at our first one here. A projectile is modeled by this expression here, and it equals h when will it impact the ground. So when will it impact the ground? What you need to do is factor and solve. And so I think factoring is going to be the easiest method here because we've got such big numbers completing the square is going to be tough because you got to divide by the -5. And also, quadratic formula is going to be tough because it's such large numbers. So I think factoring and solving is the best way. So I've got the equation. Let me just rewrite it here. -5t squared plus 18t and a plus 8 equals 0. We're going to set it equal to 0 because it's on the ground. And so we go ahead and I like to get rid of this negative sign. So I'm going to divide each side by -1 just to make the problem a little bit easier. So now 5t squared minus 18t and a minus 8 all equals 0. So let's go ahead and try to factor this now. So I'll start with the 5t and the t to make the 5t squared. And I look at it, I know they need to subtract. The outside-inside terms are subtracting. So I'm thinking I need to get a number bigger than 18. So if I do 4 and 2 like this, see this makes 20 and this makes 2. Those will subtract to make 18. So if you make this negative, that's -20. And a positive 2 make a -18. So I know the factoring's done right. So I go ahead and solve. And remember, you're setting the factors equal to 0, and you come up with your two answers. So when you do opposite operations, subtract the 2, you get -2. Divide by 5, you get -2/5. Here you add 4. And so you go with the one that's positive, because the one that's negative would be before time. So it's not really part of, it's part of the graph, but not part of the actual model of this projectile. So 4 seconds is the time it takes to impact the ground. So let's take a look at the next one here. Here it talks about the base of a triangle is 3 less than the height. So let's write that down. Base equals 3 less than the height. So that's the expression there. So here's our base right here. And it's 3 less than the height. So the height's really tall. So I'll just draw it up into here maybe, and then draw it back down. All right, so 3 less than the height. So it's pretty close to the height, but just 3 less. The area is 14. So A equals 14 inches squared. The height goes this way. And so it makes a right angle there. So this is like the height right here. Find the height of the triangle. That's what they want to know. So the area formula goes 1/2 base times by height. And so what we're going to do is 1/2, and then we've got the base, which is h minus 3. Instead of base, I'm going to use that expression of h minus 3 times by h. And this all equals 14. So we go ahead and do some work there. I'm going to go ahead and switch it around. Put the equal sign on the other side here just to make it easier for me to see. So 14 equals 1/2 h squared. So I did 1/2 times h and h times the 1/2 h. So that makes 1/2 h squared. And then 1/2 and h, so 1/2 h times -3 makes -3/2 h. So first thing I'm going to do is get rid of that 1/2. I'm going to go ahead and multiply this equation by 2. So the whole thing, every single number, including the 14. So we'll go ahead and do that. Make some room here. So I'll end up now, go ahead and write it right here. I got h squared minus 3h equals 28. So if I can factor it, that's the easiest way to solve this. And I think I can. So I'm going to go ahead and move this 28 back to the other side. H squared minus 3h minus 28 equals 0. So if I factor it, it's going to factor as h minus 7 and h plus 4. And then I go ahead and solve. I end up with an h is either going to equal 7 or -4. Well, you're not going to go with the negative number because a negative number doesn't make sense for the height. So you go with 7. So the height equals 7. So 7 inches in this case here. And it makes sense because 7, if you put 7 in for this this h right here to find the base, 7 minus 4, or 7 minus 3 is 4. 4 times by 7 divided by 2 makes 14, so it does work out. So let's take a look at the last one here. The length of a rectangle this time is 21 less than 4 times the width. Oh, lots of stuff going on here. So let's go ahead and draw a rectangle. So the length is equal to, means equals right there, 21 less. So that means you're taking 20 away from something. So that always goes last. 4 times the width, so 4w. So length is 21 less than 4 times the width. Well, here's the width. The area is 18 inches squared. So we just go ahead and do the same thing. So 4w minus 21, multiply that by w equals 18. So you do some work here, distribute that w, you get 4w squared minus 21w equals 18. And so I would go ahead and try to factor, see if you can make it work. And so that's my first step. So I'll take a look at starting with moving that 18 back to the other side. So I got 4w squared minus 21w minus 18. Factoring is always the easiest method, but if it doesn't factor, then you got to go with another method. So I'll try factoring first just to see what happens. Let's try a 4w and a w. And I want to make, since they subtract to make 21, I need 4 to multiply by something to probably make something just a touch bigger than 21. And if I try 6, you see that makes 24. And if I put a 3 here, because 3 times 6 is 18, those will subtract. 24 minus 3 is 21. To make it a negative 21, let's make the 6 negative and this 3 positive. So get two answers here. When I set them equal to 0, I get either negative 3/4 or 6. Well, you're not going to go with negative 3/4. That's a negative number. You can't have a width being negative. So you're going to go with the 6 inches here for the width. Let's see if that's what they wanted, though, real quick. They don't want that. They want the length. So we've got to do an extra step. So let's go ahead and put this 6 back in for this w right here. And so now I have length equals 6 times by 4, or 4 times by 6, minus 21. And so you go ahead and do some work there. We've got a 24. 24 minus the 21 makes 3. So length is 3. So 3 is the one that we really want. So I'll double circle that one, showing you that's the value 1. So once you solve for 1, make sure you're finding the right one. We needed to find the length, not the width for this problem. And so we have our length there of 3 inches. Well, those are some problems up through 50. Check other parts for more.